Okay, welcome back to ATAR exam preparation. We have got a question on QCAA website, external assessment. Paper 2, 2021, question 18. Now, there's only 3 marks, but it's not that easy question. So we might define this as a complex familiar because we need using needed to use calculators. However, we need to understand that the question asks what are we to do. So we got a population of an animal. The model with the animal population in thousands is grow. PT is 100 divided by 1 plus 4 e to the power of negative t. So we determine the number of animals when the population is growing the fastest. So fastest means the rates of growth is the maximum. So just try to understand the question first. Growing the fastest, that means the maximum of the rates of growth. So when you say rate of growth, maximum, so we need a derivative. So that's why I'm pre-solve this question because it takes a little bit of writing. So I'm going to show you what I do. First, I'm going to put PT into the denominator into the to the power of negative 1. All right, so then we differentiate a PT. All right, so we got negative to the front, become negative 2, then you differentiate it bracket. So that's a composite. So this is a chain rule. So the end, we got PT is 400 times by e plus 4 times by e to the power of negative t bracket to the power of negative 2, and then times by e to the power of negative t. So that's my PT, or P dash t. So this is the rate of growth, population. So in order to achieve the maximum of the rate of growth, we need to do another differentiation. So we need to differentiate the P dash t. So this is let's do the next derivative, which is second derivative. This second derivative is so we want to find a stationary point. So because we know the PT to be station, the second derivative must be equal to 0. So let's do second derivative. So derivative of P dash t is the second derivative. So let's do a double derivative. So we did a little bit so we use a product because you got u and a v. So that's u and that's v. We use a product rule. Pretty messy. So I'm finished writing to the result is the final answer should be something like that. So this is my final of double derivative. So second derivative of population. So now we let second derivative equal to 0 so that we can find a stationary. Now, if you look at the first, those two functions cannot be equal to 0 because they're all greater than 0. So the only thing I can equal to 0 is this one. So therefore, the last bracket, 4 minus e to the power of t equal to 0. So then we solve for e to the power of t, e to the power of t. So that's a t equal to 4. So we solve for t equal to log 4. There, that's using calculator, so 1.38. So that's a time. So 1.38, we suspect that's only stationary, but not necessarily be maximum. So we know to be maximum stationary point, we need to determine the next derivative. So derivative, so second derivative of p, the rates of growth, to test if it's less than 0. So we're using double derivative. So now how do I do the next derivative? So derivative of derivative of derivative. So we do, then we're going to do second derivative of the p dash t. This time I'm going to use GC. So we use GC to find double derivative of p dash t. So we can, so when a t equal to 1.386. So we're going to using graphics calculator because it take a algebraically you can do it, but take a very, very long process. I'm going to do double derivative of p dash t. So I'm using GC. Let me show you how to put in the GC. I'm using Casio calculator. We're using the maths. Then you go to menu, go to option, then you choose second derivative, which is f5. So when you put a f5, you put it those functions in, so you can see what I did. Then you plug. So if you look at what I did, move screen. Oh, I'm going to move the screen. I think I move screen. So when I plug in t equal to negative 1.38, so the answer is a negative 12.49. So that's the negative. So therefore, the p dash t, which is growth rate, has to be fastest, so maximum. So when the t equal to 1.38 years. So now we know it's a maximum, which is fastest growth. So we're substituting to the regional population. So we all found it was 49 point. Sorry, this point. So about 50,000. So because the unit is 1,000, so the year population in thousands. So it'll be 50,000 animals when the rates of growth at fastest, which is 1.3 years time. So grow to 50,000 animals. So that's a complex familiar. The reason is complex because it's using three derivatives. First, derivative 1 is rate of change. Then you do second derivative, you determine the stationary. So this is 3, 1, 2. Then you have to do third time to decide the double derivative of the first rate of growth to decide a maximum or minimum stationary. All right, I hope you understand it. This solution, the QCAA solution, doesn't actually show you that algebraically using the graphic solution. So I prefer this. But I used to use a graphics calculator, but didn't use graph solution. All right, so using algebra. So that's a good example to show you how to use calculator to do double derivatives. All right, thank you for watching. If you like the video, please give us thumbs up and don't forget subscribe to the channel. I'll see you next time. Bye.